In this video, we're going to continue our discussion of improper integrals. In particular, we're going to talk about p integrals. The question here is to determine the values of p for which the integral 1 to infinity 1 over x to the p dx converges and diverges. Let's look at the case 1, when p is equal to 1. So we have integral from 1 to infinity 1 over x to the 1, which is 1 over x dx. That's going to be equal to limit t goes to infinity, integral from 1 to t, 1 over x dx. Let's take a moment and talk about the notation that we're using. So you can see how the upper limit here is infinity. Replace that by any letter. In our case, we chose t. Then take the limit as t goes to infinity. This is the notation of improper integral. So now we get limit t goes to infinity. Antiderivative of 1 over x is log x, natural log of x, evaluated from 1 to t. Let's apply fundamental theorem of calculus. We get limit t goes to infinity. Put the upper limit in, we get log t, minus lower limit, log 1. And log 1 is just 0. So we get limit t goes to infinity of log t. So what is the limit as t goes to infinity of log t? Well, log t is an increasing function of t. That means as t goes to infinity, as t increases, the y value, which is log t, also increases and goes to infinity. That means that the case p equals 1, the integral diverges. Let's consider the case when p is not equal to 1. So p not equal to 1. What we get is integral from 1 to infinity, 1 over x to the p dx is equal to limit t goes to infinity, integral from 1 to t, and let's rewrite 1 over x to the p as x to the minus p dx, makes it easier to integrate. Now apply the reverse of the power rule, we get limit t goes to infinity, x to the minus p plus 1, and reverse the power rule and divide by the same, minus p plus 1, evaluated from 1 to t. Let's apply fundamental theorem of calculus. We get limit t goes to infinity, 1 over 1 minus p. Let's factor that out. Put the upper limit in, we get t to the 1 minus p, minus put the lower limit in, we get 1 to the power of 1 minus p. 1 to any power is, of course, 1. So we get 1 over 1 minus p times t to the 1 minus p minus 1. And don't forget to put the limit. It's so easy to forget that. Limit t goes to infinity. So now we want to find out what are the values of p that makes this integral converge and diverge. So we have limit t goes to infinity, 1 over 1 minus p times 1 over t to the p minus 1 minus 1. And let's consider the case where the exponent p minus 1 is positive. That means p is larger than 1. So if you look at the denominator, we have 1 over 1 minus p times 1 over, well, t is going to infinity. So let me write this as infinity to the p minus 1 minus 1. So here's the question for you. What happens when p minus 1 is positive? Well, this term, 1 over infinity to p minus 1, will go to 0. And we're going to get negative 1 over 1 minus p, which can be simplified if you multiply the top and bottom by negative 1. We get 1 over p minus 1. So if p minus 1 is positive, or equivalently, when p is larger than 1, we get essentially 1 over infinity, because you have 1 over infinity to the p minus 1, which will be something like 1 over infinity squared, for example. That's going to go to 0. So, or 1 over infinity to the power of 1.1. That's also going to go to 0. All right, so let's formalize that. We have integral from 1 to infinity, 1 over x to the p dx. That's equal to limit t goes to infinity, 1 over 1 minus p times 1 over t to the p minus 1 minus 1. And we show that this term will go to 0 if p is bigger than 1. So our result will be negative 1 divided by 1 minus p, multiply top and bottom by negative 1, and we get 1 over p minus 1. So that means converges. The integral converges if p is greater than 1. So let's write that conclusion down. Integral from 1 to infinity, 1 over x to the p dx, converges, and its value is equal to 1 over p minus 1, converges when p is larger than 1. So now let's consider the case when p minus 1 is negative. So we have limit t goes to infinity, 1 over 1 minus p times 1 over t to the p minus 1 minus 1. Let's analyze this. T is going to infinity. So we have 1 over 1 minus p times 1 over infinity to the p minus 1 minus 1. We're now considering the case where p minus 1 is a negative number. That means p is less than 1. So we have something like, we have 1 over 1 minus p times 1 over infinity to the power of, say, minus 2 minus 1. Well, 1 over infinity to the minus 2 is just infinity to the power of 2, so this is going to go to infinity. Let's show that in more depth. So what we have is integral from 1 to infinity 1 over x to the p dx. That's equal to limit as t goes to infinity 1 over 1 minus p times 1 over t to the p minus 1 minus 1, factoring out 1 over 1 minus p in the front. This term goes to infinity, and that's what makes it diverge. So the whole thing diverges if p is less than 1. So p less than 1, the integral from 1 to infinity 1 over x to the p dx diverges. If p is equal to 1, the integral from 1 to infinity 1 over x dx, and that's the first thing we showed in the beginning of the video, this also diverges if p is equal to 1. All right, so the summary is that if the integral from 1 to infinity 1 over x to the p dx is equal to 1 over p minus 1, if p is greater than 1, converges, and the integral will be infinity if p is less than or equal to 1, diverges. So that's basically the conclusion. Let's look at some examples. So here we have some examples of p integrals from 1 to infinity, 1 over x to the p dx, and the question is, does it converge or does it diverge? Well, the first integral diverges. Why is that? Because the value of p is equal to 1. What about the second integral? Well, this one converges. Why does it converge? Because the value of p is 1.1, which is greater than 1. Let's look at the third integral. Here we have integral from 1 to infinity, 1 over root x dx. We rewrite this as 1 over x to the 1/2 dx. This one diverges. Why does it diverge? Because the p, the exponent of x, as p is 1/2, is less than 1. Let's look at this integral. 1 to infinity, 1 over x squared dx. This converges. Why does it converge? Because the exponent is p is equal to 2, and 2 is greater than 1. Let's look at one last integral, 1 over x to the 0.9 dx. Well, this one diverges. Why does it diverge? Because the exponent is p is equal to 0.9. 0.9 is less than 1. That means it will diverge. All right, so let's look at another question. This is kind of a theory question that you might see on a quiz. Find the values of p for which the integral from 1 to infinity, 1 over x times log x to the p dx converges. And somehow we want to do a U substitution and relate this back to a p integral, something that we covered earlier in the video. So the first thing we do is apply U substitution. We're going to let u be equal to ln x. Take the derivative, du is equal to 1 over x dx. Let's look at the lower limit, x is equal to e. Plug it into u is equal to log x. That gives us u is equal to log e. Log of e is just 1. Let's put the upper limit, x goes to infinity. Plug that into u is equal to log x. Well, that means u goes to infinity, because u is equal to log of infinity, that's going to go to infinity. So let's transform the integral to get it in terms of u. E to infinity, the integral from e to infinity, 1 over x times log x to the power of p dx. That's equal to, I'm going to rewrite this as integral from e to infinity 1 over log x to the power of p times 1 over x dx. It will be easier to see the u substitution. The new transformed limit, the u limits are 1 to infinity, 1 over u to the p, because log x is u is log x, times 1 over x dx. This part is going to be just du. And this part is 1 divided by u to the p. So that's du. And so what we have shown is the integral from e to infinity 1 over x log x to the power of p dx. We transformed it and we get integral from 1 to infinity 1 over u to the p du. And this will converge if p is greater than 1. Alright, so let's do a bit of review. So what we have shown is the integral from e to infinity 1 over x times log x to the power of p dx. We transformed the limits, we did a u substitution, and what we get is integral from 1 to infinity 1 over u to the p du, and this converges if p is greater than 1. So the result follows from p integral theory that we developed earlier, namely that if the integral from 1 to infinity 1 over u to the p du converges if p is greater than 1, diverges if p is less than or equal to 1. Alright, thanks.